Let us continue with the classification of how solar energy is utilized. In indirect applications, solar energy is used to run the wind turbines. Winds are caused due to the absorption of solar energy on the Earth's surface and in the atmosphere. The rotation of Earth about its axis and its motion around the Sun. So winds are caused due to these two effects. Because of this absorption of solar energy and uneven heating, pressure differences in air are created, and these pressure differences are nothing but the wind. So the velocity of air is made use of, kinetic energy of air is made use of to run the blades, to turn the blades, which are called wind machines or wind turbines. Wind turbines or wind machines in old days find application since ancient times. In ancient times, windmills, they were better called windmills. They were used to pump water, used to grind the flour, and used to do the small mechanical work. But nowadays, with advancement of technology, windmills are called wind turbines. So windmills, they convert their rotational energy into electricity, and that electricity can be supplied to the grid. So those machines are called wind turbines. And wind machines are classified. Major classification of wind machines is horizontal axis wind machines and vertical axis wind machines. So this is the horizontal axis wind machines, propeller type, and again blade type. Further classification is there, but that classification is not the point of focus of this presentation. So this is a horizontal axis. Horizontal axis wind turbine or wind machine has a rotor. These are the rotor blades, and it has a gearbox which converts the low RPM into high RPM, and then generator takes the rotational energy and converts the rotations into electricity. So this is the general working. And in vertical axis machines, same thing, same process of flow of energy happens. Here this is a rotor, here this is a gearbox, and this is a generator. So in India, megawatt level wind power generation is fast growing. So the typical capital cost of a 1 megawatt wind turbine is 7 to 8 crores. The source is site sensitive. So this is a major disadvantage of this application of indirect application. So wind energy is site dependent. Plant use factor at the best location. Plant use factor means the amount of energy a wind turbine generates over a year as compared to the maximum amount of energy it could have generated. Means suppose a 1 megawatt windmill, it can run for 24 hours and 365 days. So that is the maximum power it can generate if we multiply that by 1 megawatt. But actually it generates 22% of that maximum power. So that factor is called plant use factor. So for the best locations in India, the plant use factor is 22%. And the efficiency of the wind turbines is of the order of 28 to 35%. So there is a wide scope. There are large wind machines spread all over India, we can say, and at the proper locations. But there is a wide scope for development of small wind machines. Small wind machines in the range of 2 kilowatt to 100 kilowatt, they find a lot of potential. So this is the scope of research and development in wind turbines. Vertical axis wind machines being high torque machines, they need vertical axis wind machines, they need high torque for starting, so they find limited application as compared to horizontal axis wind machines. This is a wind power potential map of India. You can see here the green pastures or the green shades or the green patches are the potential sites of wind. Currently in Maharashtra, we can say if we concentrate on Maharashtra, so these sides, Western Maharashtra or the interfaces of the Ghats, Western Ghats is a very good location for wind. Again, this extends to, if this line extends to Karnataka and Tamil Nadu also. Here, Tamil Nadu and Karnataka, there are a lot of wind sites available. So there is a great wind potential available in India. We can see the distribution of renewable grid power here. Among the renewable grid power, wind contributes 52.3%. So here, lot of you can see hundreds and hundreds of machines of megawatt level installed at these wind farms. These generate 52.3% power. So currently, among the contribution of renewable grid power, wind power is the major contributor in India. So India is globally placed at the fourth position in wind power generation after China, USA and Germany. So there is a great scope. Now, as I have already mentioned, there is a scope for small wind power development. At megawatt level wind power development, there are certain issues of control and all. There is some, but there is some scope of control systems and all. But it's all a high-end research field. So at the academic level, I feel that there is a scope for development of small wind machines. Now coming to now these are the indirect applications of solar energy. Now beginning the direct applications of solar energy, let us see solar photovoltaic. Solar photovoltaics, photons in sunlight hit the solar panel and are absorbed by semiconducting materials such as silicon. So electrons which are negatively charged are knocked loose from their atoms, allowing them to flow through the material to produce electricity. So due to the special composition of solar cells, the electrons are only allowed to move in a single direction. So an array of solar cells converts solar energy into a usable amount of DC. So a solar photovoltaic panel or a solar semiconductor solar photovoltaic cell converts solar radiation into DC, direct current. There are three technologies available for use in solar photovoltaics. One is thin film technology, another is monosilicon technology, and another is polycrystalline or polysilicon technology. Thin film, among these three, monosilicon crystal technology has the highest efficiency of the order of 18 to 20%. And actually on fields, we can get this efficiency to be 16%. But these are costly. These collectors, monosilicon collectors, are costly. On the other hand, polysilicon are the most popular solar photovoltaic collectors which are used in the field. They have the efficiency in the range of 14% to 16%. And the cost is also reasonable as compared to monosilicon. Thin film solar cells, they have the least efficiency as compared to monosilicon and polysilicon. So they are not preferred for power generation applications. So currently these polysilicon or polycrystalline silicon photovoltaic collectors are the most preferred ones. In solar photovoltaics, power plants, megawatt level power plants is a sensation, because the power generated from the megawatt level power plants is traded in open access. In 2003, Electricity Act has come into picture that revolutionized the power situation in India. So the power can be traded with Electricity Act 2000, with the provisions of Electricity Act 2003. Power can be traded in open access. So for solar photovoltaic can very well make use of that. So megawatt level solar power plant can trade the power in open access. They can sell the power directly to the private players. This is a snapshot of the solar photovoltaic power plant. and this is a demonstration of how sunlight is converted into electricity. So SPV grid interactive power plant, the space required for 1 megawatt power plant is 7.5 acres, that is 2.5 hectares per megawatt, and the cost is 7.25 crores per megawatt. This is excluding land cost, and efficiency of these power plants is in the range of 12 to 15%, and the best capacity utilization factor in the sunny regions is 21%. The major advantage of solar photovoltaic power plants is there is no requirement of water. They need no water. So, and the capacity or the installed capacity of the power plant can be added by modular arrangement. You can go on adding the number of modules, and the capacity of the power plant, rating of the power plant can be increased. These are the snapshots of some power plant, photovoltaic power plant installations. This is in Telangana, 100 megawatt solar photovoltaic project at Zahirabad district, Medak, Telangana. And this is 100 megawatt solar photovoltaic project at, again, Zahirabad district at some different location, Telangana. This is a snapshot of 40 megawatt solar photovoltaic project at Mandru district, Solapur in Maharashtra. This is a solar park. Now the concept of solar park is that the facilitator, you can say the installer is Enrich Energy Private Limited. So this, at the Solapur site, the land is owned by Enrich Energy Private Limited, Pune. They are in receipt of the power plant, like power producing license. Now they call for the proposals from private players to invest money into these power plants. Now you can see these building blocks: block number 1, block number 2, block number 3, block number 4. So these 4 are the investors in this solar park. This is a 100-acre solar park in which this party has invested suppose 35 crores of rupees. So for 35 crores of rupees, nearly 5 megawatt of power plant is installed by Enrich. So the EPC contractor or the installation and commissioning contractors are Enrich. So they install and commissioning the power plant on the behalf of this party A. They run the power plant and sell electricity to the parties on behalf of this party. The name of the power plant, the power plant is owned by party A. Like this, there are A, B, C, D, 4 parties. So they are in the solar park. This is called a solar park arrangement. And solar park arrangement, every day party A gets their account of investment. How much power daily they have, they are selling to the grid electricity. So it has been a very convenient model for power generation for solar photovoltaic, solar park model. In the last presentation, we have discussed the solar park model. So this solar park model in Maharashtra, this is one successful story. In Rajasthan and Gujarat, Charanka and in Rajasthan, Charanka in Gujarat, and in Rajasthan, there are a lot of stories of solar. So these are some snapshots of solar park. Now types of SPV systems are standalone system, like install the PV modules, then have a charge controller, and then load, and then battery. So this is a simple standalone PV system. Still simpler system is this: just a collector, install a collector that produces direct current, use a DC motor to pump water from a farm well, from agricultural well for irrigation. So this is the simplest systems. Government of Maharashtra has installed some systems at pilot level in some locations for irrigation purpose. Another type is grid intertied solar without battery backup. So these systems are without battery backup. These are the solar panels. Inverter converts DC into AC power. Then the power is supplied to house and the remaining power is supplied to the meter. These systems are becoming popular nowadays because you can sell excess power generated to the grid and get some advantage. Hybrid power systems are again combined with DG set and all, but these systems are still in a development stage. Standalone, this is just to explore the more detailed view of a standalone system. A typical standalone photovoltaic system is the solar panels and then charge controller. The panels supply electricity to DC electricity to charge controller. The charge is given to battery. Battery gets charged and then battery supplies DC to inverter. Inverter converts DC into AC and it goes to load. So this is standalone power system. Typical solar photovoltaic power plant works in this flow. So sunlight is incident on the solar panels, solar modules. So all the solar modules are connected with cabling to a string combiner box, and from string combiner box the current goes to solar inverter where this DC is converted into AC. Then there is a transformer, 380/33 kV transformer, AC. Then the power goes to HT switchgear, then to the switchyard, and then from switchyard through energy meter to utility grid. This is a typical flow of a solar park operation. Now the scope of work in solar photovoltaic is the solar power plants are installed over hundreds of acres of area. You can see here hundreds of acres of area. So they are in open. From all the sides the dust flows, and over a period of time the dust gets accumulated over the collector and the efficiency or the output of the collector goes on decreasing. Now for such a huge area, what should be the cleaning mechanism? Should it be automated? Should it be robotic? Should it be manual? So the automatic cleaning solution is the scope. There is a scope of business. There is a scope of development in the solar photovoltaics, because in India the rate of dust collection is very high. So there is a scope for work as a project here. So accumulate here, the point is again emphasized, the accumulation of dust on SPV collectors results in reduced absorption of solar radiation and loss of power. So there is a scope and potential to provide cleaning solution to 27 lakh hectares of SPV collector area. So you can see the potential of business, you can see the potential of development if you come up with a feasible and reliable cleaning system. So there is a scope to work in this area. So we will stop here and continue our discussion after some time for solar thermal.